Bismillahirrahmanirrahim. Assalamualaikum and good morning to my respected panel members and supervisor. My name is AMIRUL HAKIM and today I will be presenting my final year project 1. As I mentioned, today I would like to present my final year project 1 proposal entitled Framing System Design and Strength Analysis of an Eco-Tourism Riverboat. Here is a little detail about me and my supervisor. My full name is AMIRUL HAKIM bin MOHAMAD NORDIN. My student ID is 2024225458. I'm a mechanical engineering student, CEM 110 from class 4D, and my supervisor is technologist Dr. Ni Muhammad Khairuddin Ni Ismail. This is the abstract of my proposal. Ecotourism riverboats are increasingly used to support sustainable tourism and environmentally friendly transportation. The structural integrity of these vessels depends greatly on the framing systems, and inadequate designs may lead to excessive deformation and safety risks. However, limited studies have focused on the structural performance of framing systems for small ecotourism riverboats. Therefore, this project aims to design a suitable framing system and evaluate its strength characteristics. The study employs literature review, conceptual design development, CAD modeling, and material selection under static loading conditions. The analysis provides information on stress distribution, displacement, and factor of safety, resulting in a safe and efficient frame design. The findings contribute to the development of sustainable river transportation. Nevertheless, the study is limited to static loading conditions, and future work should consider dynamic loading and experimental validation. Ecotourism riverboats are becoming increasingly popular because they support sustainable tourism and environmentally friendly transportation. To ensure safe operation, the structural framing system of the boat must be properly designed. The framing system acts as the skeleton of the vessel and supports loads generated by passengers, equipment, and water forces. With the advancement of computer-aided design or CAD and finite element analysis or FEA, engineers can evaluate structural performance before the boat is physically constructed. Therefore, this project focuses on designing and analyzing a framing system that is both safe and efficient. Next, we move on to the background of study. River transportation offers an efficient and environmentally friendly mode of travel. Modern riverboats are designed to be lightweight, durable, and safe for passengers. One of the most important components of a boat is its structural frame. The frame supports the hull and distributes loads throughout the structure. Nowadays, engineering software allows designers to analyze structural behavior digitally before manufacturing it. This reduces development costs, improves safety, and helps optimize the balance between strength and weight. Therefore, this study focuses on developing and evaluating a riverboat framing system using engineering analysis methods. Next is the problem statement. The structural frame plays a critical role in ensuring the safety, stability, and efficiency of a riverboat. Current issues such as improper frame design will lead to high stress concentration in critical areas. Moreover, poor frame design may lead to excessive stress, deformation, and unnecessary structural weight. This can affect the performance of the vessel and increase material consumption. Another issue is increased structure weight. This results in lower efficiency and higher material usage of the boat. In addition, increasing passengers' loads requires strong structures without compromising the efficiency. Many conventional boat designs still rely heavily on experience rather than the detailed engineering analysis. Therefore, there is a need to develop and evaluate a framing system using engineering principles and structural analysis techniques. We move on to the objectives. There are two main objectives in this project. The first objective is to design a framing system for an ecotourism riverboat based on structural and operational requirements. The second objective is to determine the factor of safety, or FOS, of the designed framing system under specified loading conditions. These objectives will help ensure that the proposed design is safe, reliable, and structurally efficient. Next is the literature review. This chapter reviews previous studies related to ecotourism riverboats, framing systems, structural analysis, and material selection. Three main framing systems were identified, namely transverse framing, longitudinal framing, and a combination of both. The review also highlights the importance of factor of safety in boat design and discusses how structural analysis methods such as finite element analysis can be used to predict stress and deformation before construction. This is the proposed boat design. The preliminary design adopts a catamaran or twin hull configuration. A catamaran was selected because it offers better stability, a wider deck area, and improved passenger comfort compared to a conventional monohull design. The proposal boat has a length overall of 9.3 meters, a beam of 3.7 meters, and a draft of 0.5 meters. The vessel is designed to accommodate 10 passengers and 2 crew members. In addition, the propulsion system is based on a solar hybrid electric system, making it environmentally friendly and suitable for ecotourism operation. The methodology begins with a literature review to identify suitable design requirements and framing arrangements. Next, an existing riverboat hull is selected as the basis of the study. A framing system is then designed and modeled using CAD software. After selecting appropriate materials, loading conditions such as self-weight, passenger loads, and operational loads are determined. Structural analysis is then carried out using finite element analysis to evaluate stress distribution and deformation. Finally, the factor of safety is calculated to determine whether the design is structurally safe. This flowchart summarizes the entire research process. The project starts with problem identification and literature review, followed by design requirement determination and hull selection. Next, the framing system is designed, modeled in CAD, and assigned suitable materials. Loading conditions are applied, and structural analysis is performed. The results are then used to calculate the factor of safety. If the design is not safe, modification will be made before final validation. The expected outcomes of this project include a complete framing system design for an ecotourism riverboat and a validated structural model. The study is also expected to provide stress distribution and deformation results under specified loading conditions. Furthermore, the factor of safety of the framing system will be determined. Finally, recommendations will be provided to improve structural efficiency and safety. This project contributes to development of safer and more efficient ecotourism riverboats. From an engineering perspective, it provides a better understanding of structural behavior and framing system performance. From an environmental perspective, the project supports sustainable river transportation through the use of an eco-friendly vessel concept. For conclusion, this project focuses on designing and evaluating a framing system for an eco-tourism riverboat. Through CAD modeling and structural analysis, the study aims to develop a safe, lightweight, and efficient framing system. The findings are expected to contribute towards the advancement of sustainable river transportation. The respected panels, thank you for your attention. My name is AMIRUL HAKIM, and that is all from me.